This is the progress report for Team Identity. The game, the matrix. The objective, score points. Main requirements, only use the provided energy source. Build within the starting volume. Our arena is shown with 4 home zones, a 30-inch by 30-inch starting zone, an EMP blast zone, and the matrix. To win, you have to score points. This is done by completing a variety of tasks, including scoring the red pill but not the blue pill, successful egress from the EMP zone, collecting programming modules, removing sentinels from your home zone, and retrieving Morpheus. Based on the pill equation and the point values of the above tasks, your maximum points for each section are 80 points for scoring pills, 56 points for scoring programming modules, negative 39 points for removing sentinels, and 50 points for retrieving Morpheus all the way back to Zion, showing that in order, the things worth the most points are pills, modules, Morpheus, and sentinels. To understand our problem, we made a house of quality that shows that the most important parts of the design are the requirements to fit within the starting volume and to avoid disqualification through not moving or interactions with living beings, etc. Past that, scoring as many points as possible in a reliable and accurate manner are integral to a successful machine. Our spec sheet further shows this, but what it also shows is an emphasis on speed. The faster your robot, the better you're going to compete against other robots. So with the fastest robot, you'll score higher than your tandem opponents. When scoring points, you're broken down the machine into 4 main subfunctions: retrieving Morpheus, taking pills, clearing sentinels, and collecting programming modules. Breaking these down further into their components allows us to group them. Movement around the arena is denoted by a green outline. Interactions with opponents are denoted by a blue outline, and independent machine actions, generally focused on sensing, have no outline. Now we come to design concepts. For sentinels, you can either push them forward with an arm, swipe them to the side, push them forward with a roller, or spring them to the side by pushing forward. For our actual production of these concepts, we built 2 rollers, these were fairly space efficient in terms of working space, because once the ramp is used, it's moved out of the way, and the roller stays out of the machine. But the issue is that they aren't incredibly accurate, and they aren't incredibly reliable. Next, we have a shove bot that pushes the sentinel into another player's area. This is less space efficient, but it's much more reliable because it has a static range of motion that can't be changed. Next, we have our design concepts for our programming modules. We have arms that swing out via sprint mousetraps, static arms that move out of the robot and then pull inwards, nets that get thrown over the balls and then retracted, arms that swing around the balls all the way back to the edge of the home zone, and an entrapment C-channel that grabs the programming modules and prevents anyone else from touching them. For our actual production concept, we went with the simplest of the 5 concepts, which was a static arm that flung out of the robot. We've had general success with 6+ balls scored on each. Next, we have our concepts for red pill, blue pill. The first is a solenoid that releases the pills. The second is a 4-bar linkage that extends. One shoots, one drops pills as a group, and the last is a carousel that enacts with the arena. Finally, we have concepts for Morpheus: a net, a cup that drops on top of him to protect him, a string pull, and a smackback. We're just over halfway through our competition cycle, where we're focusing on figuring out the last few modules and building prototypes. We'll begin final construction in a week.